Marble, the noblest of stones, is the soul of art and architecture. For millennia, it has accompanied human civilizations and symbolized beauty, purity, and permanence. With its smooth surface, subtle luster, and natural elegance, it has established itself as a material inseparable from luxury and timeless value. From the monumental columns of ancient Greece to the glittering palaces of the Renaissance, and on to modern kitchens with polished countertops, marble embodies both prestige and sophistication. But to obtain a pristine, lustrous slab, the journey begins far from construction sites and workshops. It starts in the heart of the mountains, where the raw rock has lain dormant for millions of years. It is in these gigantic quarries, carved into the rock, that the raw material is extracted by the power of men and machines. From a massive, inert, and rough block, a long transformation begins. Each step, extraction, cutting, grinding, and polishing, acts as a succession of artisan gestures, gradually revealing the beauty hidden beneath the surface. Thanks to the combination of industrial power and human expertise, marble continues to fascinate and inspire. How has this material, so difficult to extract and work, managed to endure through the ages without ever losing its luster? Stay with us to discover the extraordinary journey of a simple, anonymous block of stone that became one of the world's most prestigious materials. Since the dawn of civilization, marble has been present in the greatest human creations. The Greeks made it the symbol of harmony. The Parthenon, Athens' masterpiece, is a shining example. The Romans, for their part, carried this material throughout their empire, using it for baths, villas, temples, and sculptures. Then came the Renaissance. Michelangelo, choosing Carrara marble, created David, a masterful work reminding us that this stone is much more than a material. It is a universal language of beauty and strength. What makes marble so special is its origin. It is a metamorphic rock, born from the transformation of limestone under the effect of heat and pressure at considerable depths over millions of years. This slow, natural process reorganizes the mineral structure, forming a dense, homogeneous, and crystalline texture. Its veins, nuances, and reflections bear witness to the passage of time and the Earth's energy. Each block of marble carries the imprint of its unique and irreducible geological history. The journey of marble begins at the quarry on the mountainside. These open-pit quarries hold millennia-old treasures. Before reaching the pure marble layer, workers must remove thick layers of earth, clay, and debris, sometimes up to 20 meters thick. These layers, of no commercial value, form a barrier between the surface and the precious stone. The miners then drill a grid of precisely calculated, deep holes into the rock. They insert carefully measured explosive charges. The explosion resounds, shaking the mountain, and clouds of white dust rise into the sky. Thousands of tons of shattered rock roll down the walls, gradually revealing the pure white veins of marble. Once the surface is cleared, heavy machinery takes over. Bulldozers, excavators, and mining trucks remove the debris to clear the extraction area. Engineers then mark the boundaries of the block to be cut with paint or lasers. Using drills, they bore perfectly aligned holes to the desired dimensions. This precision is essential. It determines the quality and value of the final block. The diamond wire is then inserted into the perforations. This steel cable, studded with synthetic diamond beads, slowly cuts through the stone, centimeter by centimeter. A continuous jet of water cools the wire, reduces friction, and removes the marble dust. The sawing can last for hours, even a whole day. Once the cuts are complete, the workers insert hydraulic jacks into the gaps. Under pressure, the block slowly detaches from the wall. A single block can weigh between 20 and 40 tons, sometimes much more. The slightest error in pressure or an imperfect cut can cause a crack and ruin the block's commercial value. Thus, a perfect rectangular prism is created, ready to be extracted. You have surely noticed that marble blocks are always rectangular. This is to optimize each cut, reduce waste, and facilitate subsequent processing. Behind this geometry lies a blend of industrial efficiency and respect for the material. Once detached, the blocks are not immediately loaded onto trucks. They are first moved to a storage area within the quarry itself. There, special low-bed trucks, capable of carrying several dozen tons, handle their transfer. These massive blocks are then lifted using crawler cranes. Steel chains and safety straps prevent any movement during the lifting process. A single error in maneuvering could cause a catastrophic fall. Once securely fastened, the blocks are placed on multi-axle trailers. These vehicles are designed to distribute the weight evenly, ensuring the stability of the convoy. The journey to the factory is slow and methodical. The trucks wind their way along narrow, twisting mountain roads. Every turn demands extreme vigilance. Once at their destination, the blocks are stored in the factory yard, ready to be processed. In the factory, each block is first positioned on a sawing bench and held in place by steel frames and hydraulic jacks. This is where the multi-blade saw comes in, a gigantic machine capable of handling blocks weighing up to 40 tons. Equipped with dozens of parallel blades inlaid with industrial abrasives, the saw begins to move. In a steady back-and-forth motion, it slowly slices the block, one after the other, into slabs a few centimeters thick. Since the blocks have already been cut into rectangles at the quarry, the cut is precise and optimized, minimizing waste. Sawing a block can take from 12 to 20 hours, depending on its hardness. Each slab, approximately 2.5 centimeters thick, weighs several hundred kilograms. Once the sawing is complete, the slabs are numbered, sorted, and stacked. Cracked pieces are set aside. Only the perfect specimens proceed to the next stages. It is in this phase that the marble begins to reveal its natural luster. The still rough and dull slabs are placed on an automated production line. Robotic arms equipped with suction cups move them carefully, avoiding any impact or scratch. They then pass through a grinding system equipped with rotating heads covered in abrasive discs. Each head uses a different grit size. Coarse discs level the surface. Finer ones polish and refine it. Water plays a crucial role. It cools the discs, prevents overheating, and removes marble dust. Complete polishing requires between 7 and 8 successive stages. Gradually, the surface becomes smooth, satiny, and then lustrous like a mirror. The veins and nuances then appear clearly, giving each slab its unique identity. The final polishing uses special compounds that enhance the brilliance and depth of color. It is at this stage that the commercial value of the marble is determined. Only perfectly uniform and brilliant slabs will be retained. The large polished slabs are then transported to another area of the factory, dedicated to cutting into tiles. On a conveyor belt, the slab is held in place, and then a diamond-tipped circular saw begins to cut it into standard dimensions: 30 by 30, 45 by 45, 60 by 60 centimeters, or according to custom orders. During cutting, a constant jet of water cools the blade and prevents chipping. This process ensures clean, crack-free edges. The tiles are then dried, sorted, and carefully stacked. Some slabs intended for monumental architecture remain whole. Others, thinner, are designed for wall cladding, countertops, or interior decoration. Once the polishing is complete, each slab passes under a laser inspection system. Beams of light scan the entire surface, measuring flatness, gloss, and thickness to the millimeter. The slightest defects, micro cracks, variations in color, or irregularities are immediately detected. Only slabs meeting the strictest criteria are approved for sale. Before packaging, workers perform a thorough cleaning with pressurized water to remove all traces of dust or chemicals. The slabs are then dried and placed on wooden or steel pallets. Between each slab, foam or rubber pads are inserted to prevent direct contact. The entire stack is then strapped with metal bands and wrapped in protective plastic. Each pallet is labeled with its dimensions, batch number, and destination. The finished blocks are then loaded onto trucks or into shipping containers, ready to be shipped to markets around the world: Europe, the Middle East, the United States, and Asia. The marble's journey, which began in the heart of the mountain, reaches its industrial end here. Not all marble ends up as tiles or slabs. Certain blocks, chosen for their exceptional purity and homogeneity, are reserved for sculptors. Their work begins with the design. Sketches and models in wax or clay help define the final form. The sculptor then marks the working guidelines directly onto the stone with chalk. Using diamond-bladed saws, drills, and pneumatic hammers, he removes large masses of material to sketch out the volumes. Then comes the roughing out, where the raw block takes shape. A silhouette emerges, the proportions are defined. The tools become finer, flat chisels, points, and chisels. The sculptor's hands alternate between strength and delicacy. Every stroke counts. A mistake could create an irreparable crack. Once the form is complete, the sanding and hand polishing phase begins. Increasingly fine abrasive papers erase the tool marks. The marble becomes smooth to the touch. Polishing powders mixed with water are applied in several layers to reveal the depth and brilliance of the stone. Finally, the light begins to play on the surface. The veins, the transparency, and the texture create an almost lifelike impression. This meticulous process transforms an inert block of stone into a work of art, an eternal sculpture, a symbol of the connection between nature and humankind. From the heart of the mountains to the masterpieces in museums, marble undergoes an impressive chain of transformations. Each step demands precision, patience, and expertise. A miscalculation during sawing can cause a crack and ruin several tons of material. Excessive pressure during extraction can undo weeks of work. This journey, both industrial and poetic, reminds us that behind each gleaming slab lie millions of years of geological formation and weeks of human labor. Marble is both a witness to time and a collective work, that of the earth, machines, and artisans. So what impresses you most? The raw power of the mountain as it yields a colossal block of stone? Or the infinite delicacy of polishing that reveals the subtle veins and the light of the marble? Tell us in the comments. If you enjoyed this documentary, don't forget to like, subscribe, and turn on notifications so you don't miss any of our content. But don't go away just yet, there's more. The rest of this video will be just as exciting, so stay with us until the end. Did you know that the Brooklyn Bridge has been standing for over a century thanks to more than 22,000 kilometers of steel cables? But what is it about their manufacturing process that allows these steel wires to support such colossal structures? To create a cable that is strong, durable, and reliable, capable of serving in situations where life may depend on it. It all starts in iron ore mines and continues to steel mills. There, the alloys are melted at extreme temperatures, cast into billets, and then subjected to rigorous inspections before being drawn into wire and twisted to form the finished cables, ready to equip projects around the world. This documentary takes you through the entire process, from the technical details and monumental machinery to the finest operations, to explain how what appears to be a simple bundle of braided steel can last for decades in the harshest conditions. Steel wire rope was born in the 1830s, deep in the mines of Germany, when hemp ropes were no longer sufficient to support the loads. By replacing these old ropes, loads could be lowered hundreds of meters underground in complete safety, paving the way for large-scale industrial exploitation. Nearly 2 centuries later, this material has become established in almost every field. Each year, the world consumes more than 10 million tons of steel cables used in infrastructure, heavy industry, oil and gas, shipping, and even renewable energy. Millions of elevators worldwide depend on them, allowing skyscrapers to rise and shaping the silhouettes of our modern cities. What's truly fascinating is the relationship between their small diameter and their impressive load-bearing capacity. The twisted steel wire bundles not only provide flexibility, but also distribute forces evenly across their entire cross-section. Thus, a cable just a few centimeters thick can support hundreds of tons, a true mechanical marvel of the modern world. The steel cable's journey begins in the vast iron ore mines, buried deep underground. Powerful drills penetrate the rock to create holes for explosives. Controlled detonations fragment the rock, releasing blocks of reddish-brown ore. Huge hydraulic excavators then lift these blocks, sometimes weighing several dozen tons, and load them onto trucks capable of carrying hundreds of tons at a time. These trucks travel tirelessly along dedicated routes, transporting the ore to the surface. At the storage site, the ore is poured into hoppers before being transferred onto long conveyors. Their vibrating screens and magnetic separators remove soil, sand, and coarse impurities. The finished ore is often crushed into smaller pieces for easier transportation and subsequent smelting. Specialized rail cars and giant cargo ships then take over, each carrying thousands of tons. This extraction and preparation cycle operates continuously, guaranteeing a constant supply for the steel industry and ensuring the availability of the raw material needed to manufacture cables. When the ore trains arrive at the sawmill, the smelting process begins. Thousands of tons of iron ore, mixed with recycled scrap metal, are fed into a gigantic electric arc furnace as tall as a building. Inside, enormous graphite electrodes pass a colossal current, generating heat of over 1,600 degrees Celsius, enough to transform the solid metal into a molten mass similar to volcanic lava. To give the steel its specific mechanical properties, engineers carefully add manganese for strength, chromium or nickel for corrosion protection, and silicon to improve ductility. At the same time, bat and fluorite are added, forming a layer of slag on the surface. This slag acts as a natural filter, absorbing impurities and refining the molten metal into cleaner, stronger steel. The mixture is continuously stirred by powerful electrodes, while modern sensors monitor the chemical composition with extreme precision, ensuring that each batch meets strict standards. Once the steel is purified and its composition adjusted, it moves on to the continuous casting stage. Unlike in the past when the metal was poured into water, today it flows continuously into copper molds cooled by circulating water. Upon contact with the cold walls, the outer layer immediately solidifies, while the core remains liquid. Solidification progresses from the outside to the inside, forming billets several meters long, generally with square or rectangular sections. Upon leaving the mold, still heated to thousands of degrees, they are sent directly to the primary rolling mill to take advantage of their residual heat. Gigantic alloy steel rollers then exert considerable pressure on the billet. With each passage between the cylinders, it flattens and lengthens, reducing its thickness and increasing its length. The process is repeated several times, gradually transforming the billet into semi-finished bars, plates, or slabs. The high temperature keeps the steel ductile, preventing cracks, while repeated mechanical forces realign its internal structure, making it more homogeneous, stronger, and more stable before drawing. After hot rolling, the material moves onto the cold rolling line to be reduced into extremely precise wire. The red-hot bars are first cooled by a pressurized water jet, then pass between a series of cylinders that gradually lengthen and refine them. With each pass, the metal's cross-section decreases, transforming it into round or flat shapes ready for drawing. During this stage, the wire passes successively through dies of increasingly smaller diameters. Each pass makes it finer, smoother, and more consistent. This process, carried out at room temperature, requires careful control of tensile force, speed, and friction. Even the slightest variation can result in breakage or loss of ductility. In modern factories, laser sensors continuously measure wire diameter with automatic correction systems that adjust the tension in real time. The result is coils of steel wire with near-perfect precision, providing the strength essential for cable manufacturing. But achieving the right size is only half the battle. To fully meet the mechanical requirements, the wire must undergo a crucial step: heat treatment. It is heated in a furnace at very high temperatures, between 400 and 800 degrees Celsius, in a strictly controlled atmosphere. The heat modifies the internal crystalline structure of the metal, reorganizing the grain network to achieve an ideal balance between hardness and elasticity. Once the desired temperature is reached, the wire is immediately cooled by air jets or immersed in an oil bath, thus fixing its new structure. Next comes the anti-corrosion coating. Depending on its final use, each wire receives a protective layer, usually zinc or polymer. Exposed to moisture, salt water, or chemicals, this invisible shield prevents oxidation. Before being coated, the wire is carefully cleaned with a mild acid solution to remove grease and rust. It is then dipped in a bath of molten zinc or coated with a polymer heated under controlled pressure. The coating must be uniform and perfectly adherent, as the slightest air bubble could compromise the entire lifespan of the cable. After this protection, the wire undergoes a complete inspection. Sophisticated sensors check its diameter to the nearest micrometer and detect the slightest deformation. At the slightest anomaly, the wire is immediately discarded. This drastic selection ensures that only the strongest wires continue their journey to the wiring workshop. There, hundreds of spools are installed on large rotating machines. By rotating around a central axis, they braid the wires together in a precise pattern. The core of the cable can be made of steel for maximum strength or synthetic fiber for greater lightness and corrosion resistance. The wires are first grouped into bowls, then several bowls are wrapped around the core to form the final cable. Throughout the process, sensors measure tension and twist angle to maintain perfect uniformity. If a wire is too tight or too loose, the machine automatically adjusts the pressure in real time. Once the stranding is complete, the cable receives a coat of oil or industrial lubricant applied by immersion or pressure spray. Winding speed and liquid flow rate are controlled to ensure even impregnation. These oils, often enriched with anti-corrosion additives, provide long-lasting protection, particularly for cables intended for marine environments. Before leaving the factory, each cable undergoes extreme testing. Tensile testing to breakage, repeated bending, dynamic load testing. Only those that pass these tests are validated. Then they are wound onto metal reels, filmed to protect them from moisture, and labeled with a traceability code. Automated cranes move these coils to the logistics area where they are loaded onto trucks or special containers, ready to be shipped to construction sites around the world. From the raw ore block to the high-strength steel cable, each step demonstrates the precision and technological power of modern engineering. Behind each wire lies expertise, where every detail is important. If you like this documentary, don't forget to like, subscribe, and hit the bell so you don't miss any of our content.